Hello everyone, welcome to Bright Labs and welcome to this lesson on limits in calculus. Today we're going to take our first big step into the world of calculus by learning one of its most important foundations, limits. Whether you're totally new to this or need a refresher, this presentation will guide you through it all in a way that's simple and easy to follow. Let's jump right in. So what is calculus? First of all, in simple terms, calculus is the branch of mathematics that studies change. When things move, grow, shrink, or accelerate, calculus is the tool we use to understand and measure those changes. It's divided into two big parts: differential calculus, which focuses on rates of change like speed or slope, and integral calculus, which focuses on accumulation, like finding areas or total values. But here's the thing. Both of these areas are built on a single powerful idea, limits. That's why we start with limits before we can go anywhere else in calculus. So what exactly is a limit? A limit is what a function approaches as the input gets closer to a certain number. Think of it as asking what is a function trying to do as x gets really close to some value. For example, let's say we have a function f of x, and we're interested in what happens as x gets closer and closer to a number a. If f of x gets closer to some number, like f of a, we write it like in the notation example, and yeah, this doesn't mean x ever reaches a, and it doesn't even mean the function is defined at a. It's all about approaching. Why are limits important? Why do we care about limits? Because they allow us to study functions at points where they might not even be defined, or at points where strange things happen. Limits are also the first step to defining things like derivatives and integrals, which are the core of calculus. When we calculate the slope of a curve or find the area under a graph, or try to figure out how something is changing at a specific instant, we're using limits, even if we don't realize it. So mastering limits is like learning the alphabet before writing a book. And here's an intuitive example. Suppose we have the function f of x equals x squared. What is the limit as x approaches 2? Well, if we try values like 1.9, 1.99, 2.01, and 2.1, and we plug those into the function, we'll see the output, x squared, getting closer and closer to 4. So we say, as in the example, even without plugging in 2 directly, we can still figure out what the function is approaching. That's the power of limits. Now, one of the best ways to understand limits is with a graph. Imagine the curve of a function, and you're walking along the curve toward a particular point from the left and the right. What value are you getting closer to? That value, if it exists, is your limit. Graphs helps us visualize whether the function is smoothly approaching a value, jumping, or doing something weird. We'll see examples of that in a moment. One-sided limits. Now let's take this a bit deeper. Sometimes we care about what's happening on just one side of a point, and that's where one-sided limits come in. The left-hand limit looks at values of x approaching from the left, and it's written like so, while the right-hand limit looks at values approaching from the right. If both the left and right-hand limits exist and are equal, then the two-sided limit exists. But if they're different, then the limit doesn't exist at all at that point. So when does a limit not exist? Well, there are a few scenarios. If a function approaches different values from the left and the right, if the function goes up to infinity, or if the function just jumps or oscillates too much to settle on a value. Take this as an example. As x approaches 0 from the left, the values go to negative infinity. From the right, they go to positive infinity. Since they don't agree, the limit doesn't exist. And here are the basic rules that make working with limits easier. These are called limit laws, and they let us break down complex expressions into simpler parts. Let's say we know the limit of f of x and g of x as x approaches a. Then the limit of their sum is just the sum of the limits. The limit of the product is the product of the limits, and the limit of the quotient is just the quotient of the limits, as long as we're not dividing by 0. These rules let us build limits piece by piece. One of the easiest ways to evaluate a limit is by using direct substitution. If the function is continuous at the point you're interested in, just plug in the value. And here an example, we just plug in the values and the limit is 7. It's super easy, really. But it's not always that easy. Sometimes plugging in the number gives you something weird, like 0/0. That's called an indeterminate form. It means we need to do more work, usually by simplifying it, as shown here in an example. And in the end, the limit is 4. What about functions that change their rule depending on x? Those are called piecewise functions. To find the limit at the place where the function switches, you need to check the left and right sides separately. Now let's talk about infinite limits. These happen when the function keeps growing larger or smaller without bound. And here are some examples, and these don't have a real number as the limit, but we can describe their behavior by saying the limit is infinite. What about when x gets really, really big? That's the limit at infinity. Here we ask, as x goes to infinity, what does the function approach? As x gets huge, for example, if we had a limit where x approaches infinity, 1/x equals 0. As x gets huge, 1/x gets smaller and smaller, approaching 0. So the function flattens out near the x-axis, and this is how we understand and behavior of functions. Let's wrap up. Today we learned what a limit is, why limits matter in calculus, how to evaluate limits using substitution and simplification, why limits don't exist and how to recognize it, what infinite and one-sided limits are, how limits help us prepare for derivatives and integrals. And yeah, thanks for watching and keep practicing. If you have any questions, leave them in the comments down below, and the better you understand limits, really the easier the rest of calculus will be.